I will speak today in a very simple language so that everybody can understand. As Einstein once said that you have to polish your theory that you can explain it to your grandmother and she will understand. With the publishing of general relativity in 1916, the subject of gravity is the core subject of physics, was stolen by mathematicians. And now mathematicians are protecting this area. This area has become their area of research. Gravity today is a subject of mathematical physics. And mathematical physics is not a science. Mathematical physics is philosophy, where mathematics is used as a tool to develop mathematical philosophy. A general relativity is not a physical theory. This is a mathematical philosophy. Which has a huge holes. It's like a Swiss cheese with the big holes inside. And mathematical physicists, they don't want to see these big holes in the cheese. They say, no, there are no holes in the cheese, but there are big holes. And the biggest hole is that in mathematics of general relativity, the mass m is not directly involved in this mathematics. So generally speaking, we have a curvature of space but this curvature of space as a mathematical model is not directly related to the mass. And this is the key problem, the core problem of general relativity. As general relativity requires extensive knowledge of mathematics, most of the people don't understand what is going on there. So they just follow this mathematics of general relativity as a kind of religion that we cannot grasp intellectually, but we believe it is the greatest, one of the greatest achievement of physics. Because today, in a mainstream physics, a general relativity is acknowledged as one of the pillars of physics. And if you have a good intentions to show the weak parts, the weak holes in the cheese of this cheese, they say no, you don't say anything against this model because this is the best of the best. Here is the core problem. So, the development of general relativity naturally goes in the direction that we develop a mathematical structure. We develop a mathematical model where mass will be directly involved. Because the weak point of general relativity is you cannot calculate the force between, let's say, moon and earth. So what is the purpose of a mathematical model which describes gravity if you cannot calculate gravity force directly? We can calculate gravity force with a Newton formula. So we have to understand here deeply what is mass. How mass energetically is related to the environment in which the mass exists, to the medium, to the space. And here was a cardinal mistake of Einstein, that he threw ether out of physics. Four years after general relativity was published, he had a big speech, I guess in Leiden, to explain that gravitational physics cannot miss gravitational ether. But it was too late. The subject of gravity was stolen by a mathematical physicist. And still today, a gravity research is in the domain of mathematical physicists. So the core question is how to relate mass of a given object with the space, in which relation are mass, let's say mass of our planet Earth, and the space in which this mass exists. This is the core question of gravity development. So when we suppose that this mass is in the medium, it naturally occurs idea that this mass diminishes density of the medium. And actually this is not a new idea. This is already Newton idea. Newton was talking about gravitational ether, actually about ether, and that ether diminishes, that the stellar object diminishes density of the ether, and that this generates gravity. So what I did years ago is to formulate mathematically this Newton idea. And the mathematical formulation of this Newton idea is based on the mass energy equivalence principle extension on the medium, on the superfluid quantum space, we can say, or on the quantum vacuum, or dark energy, or ether. These are the same terms for the physical reality in which everything exists, for the medium. So Earth, we have now planet Earth, and this planet Earth diminishes density. Now how to formulate this in mathematical terms precisely? We have Planck units, and the Planck units, this is one of the most beautiful creation ever in physics. So we have a Planck mass, and we divide the Planck mass with the Planck volume. We get a Planck density, and we multiply this with c squared, and we get a Planck energy density. And the Planck energy density is the density of the medium in the intergalactic space. When we have a certain stellar object, then the energy density will diminish. Will diminish in the center of the stellar object, exactly correspondingly to the mass of the object. The bigger is the object, the bigger is the mass of the object, the lower is energy density in the center. And when we have two objects with the same mass and the one is much smaller, then the energy density in this smaller will be less, will be smaller. So the equation, the exact mathematical equation is this is a classical equation of the Einstein, and now we add here is a Planck energy density minus energy density in the center of the Earth by the volume of the Earth. This is the mathematical formulation of the energy relation of a given mass with the given object, with the given physical object. And this equation is valid also for relativistic physics. We add here Lorentz factor, and here because of this then the energy density in the center is lower. But anyway, let's go on with the relation mass and energy density. So out of this equation then we get mass is equal Planck energy density minus energy density in the center per volume divided with c squared. This is the mass. But this actually is not a mass as an amount of energy, but this is gravitational mass. Gravitational mass is the result of the given object, of the given mass in the space, because the space gets diminished, energy density of space in the center is diminished, and then we have a pressure from the outer space towards the center. And these are inertial and gravitational mass. They are equal. And out of this we can then calculate gravity. So the gravity force is gravitational mass 1 by gravitational mass 2 by constant gravitational with the with the r square. This means that it's not a curvature of space carrying gravity. Gravity is a vector of space which is based on the variable energy density. And this has huge consequences in gravitational physics, because the gravity inside black holes obey the Newton shell theorem. So when we go in the center of the black hole, which actually there is no hole there in space-time, because space is not curved. This is the better name would be black star. When we go in the center of this black star, which is highly dense, when we come in the center, the energy density there is extremely low. But the gravity there is zero. Gravitational singularity is a mathematical outcome of the wrong idea that space is curved. So what happened in the center of the black hole is that because of the extremely low energy density of the medium, the electromagnetic properties there are changed. And atoms become unstable. So in this model of gravity, gravitational singularities are changed with the area where the atoms become unstable. We know in physics that reduced Planck constant is Planck mass by Planck length by light speed. If instead of mass, if we express the mass with the variable energy density, we get out that the Planck constant is a Planck energy density by Planck distance on the fourth divided with c. And this equation has immense power and beauty, because the medium is not three-dimensional, the medium is four-dimensional. This fundamental medium, this fundamental energy, which is the energy substratum of the space, is four-dimensional. And this equation is valid in the entire universe, except a black holes, because in the black holes the energy density of the medium is so extremely low. Here it's so low that the Planck constant diminishes its value. And this changes electromagnetic properties of space. And that's why the atoms become unstable. The atoms fall into elementary particles. And inside the black hole, a huge amount of fresh energy is created. The black hole is eating itself. That's why we have explosions of supernova. The black hole explodes because the gas inside the fresh gas. When the star is too big to explode, then this pressure of the gas makes a holes in the direction of the black hole's rotation. And this is the case with the supermassive black holes, where we have these huge jets of of fresh energy coming out of the active galactic nucleus of spiral galaxies. So in this perspective, universe is recreating itself. So the Einstein idea of curvature was good for his time, but now to protect this model as the model that cannot be improved is a mistake, because already out of the curvature we have now this mistake, this misunderstanding of gravitational singularities. So we can improve physics by recognizing that certain models are outdated and that we have to build something that is better, that makes more sense. NASA has discovered in 2014 that the universal space has Euclidean shape. So since then we have to work, and I do this, we have to work on the fact that the curvature is just a mathematical description of some fundamental properties of space which are physical. This is the weak point of general relativity, that the curvature of space cannot carry gravity, but the variable energy density of space can carry gravity. So thank you for your attention. I will send this article now in the peer review, and I hope that the peer reviewers will see that all this makes sense, and that it will be published, because the progress of science is in the confrontation. Today we have a very particular situation in physics, that everything what is new is refused before the peer review. So everything in physics that is new will never reach to the peer review. This is a policy of many journals. I sent this preprint that is under this article, under this video. I sent this article to several journals, and nobody was ready to send the article in review. Everybody say thank you, polite letter, thank you, yes, but your article is not in the policy of our journal. That's why we have such a huge crisis in physics, because we are stuck in the old paradigm. And when someone creates something that it makes sense, but it's a little bit out of the old paradigm, the editors will say no, this is not physics. And here we are. So I wish everybody a good day and check this preprint. If you work on the gravitational physics, I warmly invite you to check this preprint, because it makes sense. Together we will do it.